Just trying to make the video be available to you guys. There you go. All right, so certainly don't want to minimize that one. Yeah, so okay, so you interjected there. But a very solid point there by it was Casey about electrolysis, and Deborah saying that it's the definition there is what the passing of current through an ionic solution. Probably we might want to write that as well because that is major. I can't emphasize.
So you said it last week and I wrote it. You said it last class.
Oh, I said it last class, which is good. All right, so that was well done of myself. Told the last class, very major stuff, guys. Electrolysis is all right. So one, say what you said though, Deborah. What is, say what you said before.
To the passage of current through an ionic solution.
Passage of current through an ionic solution. All right. Yeah, I'll accept that. Definitely. It's I guess persons who are very technical about chemistry would say that it's the passing of current through an ionic compound that is in an aqueous or molten state. Think if a person would tell me that that's how I should say it, I will agree with them because that's a better way to say it. So and the only reason I gave you a sort of easy definition, but when you want to get technical chemistry, setting it up for future stuff, I would be more detailed in the definition. So then that the passage, so it's actually passing current. I feel like teaching you guys electricity today. It's something that's on the syllabus. So this is afterwards we're going to look at the objectives that CXC wants us to know for this one. But passing current through okay, so and yeah, we're gonna say that an ionic any compound in its molten or aqueous state. Now, we're gonna get really, really specific here, because these words are crucial: molten and aqueous. All right, and of course the ionic compound, and of course the current. Now, I was doing a little bit of search through some past papers, and I came up across quite a few questions that combine the bonding, and this concept here. So let's go. In fact, one of those papers I had loaded before class I started. Let me just see if I can locate it. There you go. This was actually from a 2016 paper. All right, so everybody can see this.
Yes, sir.
Yes, sir.
All right, so yeah, 2016 June paper, and it was indeed it's the first, I would say actually the second paper from the syllabus that we're using. So the syllabus that we are using now is 6 years old this year. So they changed it 2015, and then 2016 now would be the second year when they would use that syllabus to set this exam. So the best past papers right now, it would be from 2015 coming right down for the sciences, because that was the year that they changed the syllabus for physics and chemistry and biology as well. But this question, if you can see it, all right, now they are going They're just throwing it at you. All right. What it says here: dilute sulfuric acid is the electrolyte used in car batteries. All right. Remy obtained a sample of this electrolyte from a car battery and carried out an investigation on it using electrolysis. All right, hold on. This I need to underline some words here. You know, in exam, that's one of the tools that you use to work your way into the exam. Start to underline, you know, warm up your fingers then with the pen by underlining the main parts of questions. All right, so what it says here, so I'm take a, all right, so Remy, I don't know if this is a male or female. There's some Trinidadian name though. I know nobody in Jamaica, I don't know with this name. They must be Trinidad, certainly not Barbados. Even probably Guyana, but then they don't set, I hardly see them set a paper about Guyanese things. So I'm gonna say that this is a Trinidadian question, just by the names they're using. But this person obtained a sample of electrolyte. Now, let's go back to what we were looking at. And all I basically teach about electrolysis to this point is the definition. All right, let's go back to this. All right, now, so when a ionic compound is in its molten or aqueous state, it collectively we call it what's that word?
Electrolyte.
Mm-hmm. All right, that's a term for it. So when you learn about ionic compounds now, fine, you know about bonding, you know to write formula, right? Now we are learning how we can actually manipulate these ionic compounds now. So we can melt it or we can dissolve it. Aqueous compound is one that is dissolved in water. All right, so let's write that. So aqueous means that the ionic compound is dissolved in water. All right, and molten means that it is it's just molten as it is. So molten means only two ions are present in it. So that means no are present. All right, so in its liquid state. So then this is like to have a molten ionic compound. It's like you take you have some salt, which is an ionic compound, and you use a torch and melt it, because that can be done. Remember that ionic compounds have high melting point, right? So you would need something like a torch to melt it. And then when you use a torch on it, like a blow torch, really high temperature, a torch can give you up to like 3,000 degrees Celsius. You bring that, you know, with a pack of salt, for example, it's gonna turn into liquid, and it's gonna be molten, not aqueous. All right, that's the difference here. And what happens here is that only two ions will be present. So, but then it's still an electrolyte. Once it is molten or aqueous, it is an electrolyte. The only difference is that if we say molten, then we know that it's only the two ions in the compound that is given. So usually for these questions, they give you the name of a compound, and then now you start to figure out, okay, it's an ionic compound. It will have two ions if it's molten. If it is aqueous now, we have a situation now where we have the two ions. So let us say we're talking about sodium chloride now. And I give you an example here. It's like NaCl. We'll write this as L. What do you think the L mean?
Liquid.
Liquid.
Very good. And then this now I write another NaCl, but this time I put AQ in a bracket there. What does AQ mean?
Aqueous.
Aqueous or dissolved in water. So there's a difference here. So these are the clues that you're going to look for in exam questions. All right, the sodium chloride in the liquid state is the one that's molten. Everybody get that?
Yes, sir.
Yes, sir.
All right, so this one is molten. NaCl in liquid state is molten. But NaCl now in with the AQ there means that what? This one is dissolved in water. So there you go. You have your two types of electrolytes there. All right. Any questions here so far?
No, sir.
All right. So remember when you're doing electrolysis, and then let's put the broad name of the topic here, electrolysis. All right. Electrolysis, as I said, for that to happen, the compound that you're using must be in a liquid state, whether you want to melt it or you want to dissolve it in water. Either way, it must be, it must be in a liquid state. All right. Now, let's go back to that question. So, since you understand the principle of electrolysis now, and you see this question, dilute sulfuric acid is the electrolyte used. Now, you have been learning to write formula now, and then you might be wondering what on earth is the formula for sulfuric acid. Now, I haven't taught you about specific types of ionic compounds. What I've done so far is to teach you general ionic compounds, some common ones, but I haven't mentioned the acids in any of them. Neither have I mentioned base. Well, I think I mentioned a few bases, but I didn't tell you that it's a base. So all right. So in this case now, what you're going to learn here is that some ionic compounds will be acidic based on the rule that some ionic compounds that contain hydrogen in them have the ability to give it up in a reaction or to release the hydrogen in a reaction. And when it does that, it forms a salt, which is another type of ionic compound. So we have about 6 of them to know, but we'll do that later on. But point is that sulfuric acid has a formula which they expect everybody who doing CXE is supposed to know. Sulfuric acid is perhaps the most common acid in questions if they're asking about acid. Yeah, sulfuric acid, hydrochloric, and I believe I taught you that last year, but then again, you forget. So let's go. Sulfuric acid. If you go back to your notes last year, anybody remember the formula for sulfuric acid?
H2SO4.
Very good. This is something that you don't forget. From the first couple of times I was told this other student, I never forget it. Wake me up any hour or night in my sleep, I can tell the formula of any acid, or at least any strong acid. This is one of them, sulfuric acid. So H2SO4 is what's there. Now, if I were to ask, what two ions would be, well, they said dilute, so there's a little trick here. So now, what do we use to dilute things?
The water.
Yeah, yeah, that's the most common thing we use to dilute. So therefore, it's telling you that this is in there, but the dilute means that water is there too. This is another way of saying it's an aqueous substance. See that? So CXE can use other words to imply whether an electrolyte is aqueous or molten. All right. So dilute means the water is there, and then sulfuric acid has this formula. This is telling you a lot of stuff. All right. So what we have here is the compound that we're dealing with. We are told that it is an electrolyte. A student who is going to get a grade 1 in chemistry at this point going to say, this is the common knowledge. However, you're learning it now, so you're not going to say that. But then you're going to say, all right, so you have water and sulfuric acid used in car batteries, and Remy obtained a sample of this electrolyte from a car battery and carried out an investigation on it using electrolysis in the laboratory. So yeah, they're setting you up to ask you a bag of questions here. All right. So everybody understand what I'm saying so far? You have any questions about it?
Awesome.
Okay. All right, good. So all right, so dilute means water is in there, sulfuric acid has a formula H2SO4. And they ask what is an ion. Now, I tell you, when you're approaching exam at this stage, I'm going to tell you to figure out the question before you start working. When I say figure it out, when you see them ask you something, it's like you're going to do an interview, right? And you know there are certain things they're going to ask you, right? But they know that. Yeah?
Yes, sir.
Yes,
Yeah.
sir.
All right, good. So you prepare yourself. The same thing with this now. Anyhow, them start asking about electrolyte, be prepared for a certain question. What is an anion? What is a cation? What is electrolysis? One bag of question can follow. So at this stage in the question now, and I guess maybe because I'm a teacher now, I get more you know, you call it now. I'm able to predict or discern what they're trying to do here. But what I'd want you guys to do here, let me just get a new page and show you something. All right, we have water, which has the formula H2O, and we have H2SO4. Suppose I ask you what two ions are present in sulfuric acid. Which ions you tell me?
2 ions,
Yeah.
sulfate and hydrogen.
Yeah, just like that. Everybody hear that?
Yes, sir.
Simple enough. Yeah, sulfate and hydrogen. Can you recognize this? Let's go H2SO4. This is the reverse now. So you get the formula. We're going to break them into ions. All right. Let's look at something here with water. Let's look at something here, sulfuric acid. All right. So we're saying to get sulfuric acid, it's going to be the sulfate ion, which is SO4 with the 2 minus there. The hydrogen part there, which is H plus. All right. So let's write the name of it. And then the name of it here. This is the sulfate ion, and this is the hydrogen ion. No, the sulfate ion has a negative charge. What name do we give to ions that have a negative charge?
Anion.
Right.
Anion.
Yeah.
Anion.
Yeah, very good. Anion. That's on week tonight, man, or this evening. And that's on like on already. All right. So yeah, that's an anion, which would make hydrogen ion what now? The opposite of anion is what?
Cation.
Very good. So we have that there. All right. So this is good. This is good stuff. You can apply yourself now. So you know what an anion is, you know what a cation is. We know that sulfuric acid will have these two ions. Let's go to water. All right. Now water. All right. If you're applying the knowledge the right way, what type of compound is water?
Water.
Yeah. We're using like covalent, ionic. Which one of those?
Covalent, sir.
Water is covalent. So how it end up here then? How does it come to have ions? Because covalent compounds don't have ions. So what I'm going to teach you now is that yes, water is a covalent compound. However, due to the nature of oxygen and how it reacts with hydrogen, it's not an ordinary covalent compound. Water is what we call a polar covalent compound. All right. And of course, this would be sort of ionic, but polar covalent now means that it's a covalent compound that behaves like an ionic compound. So it has poles. Now the poles are plus or minus. So what I will show you today, maybe for the first time, is this. Water can form two possible ions, or can actually it's said to have these two ions in it when it reacts or dissolve something. All right. So it's gonna have this H plus and OH minus. Now we already know that the H plus is the hydrogen ion, but what is OH minus?
OH hydroxide.
Okay, good. So that's a cation. Very good. So hope everybody hearing that OH means hydroxide ions. So that's what we're going to look at there, hydroxide ion. And of course, we know that that's an anion. So all right, so we're breaking this down now. So guys, every time water is in a compound, are in a substance, it will always have these ions present. All right. Hope everybody is listening to that. All right. So when water is there, hydrogen ions automatically in there. Hydroxide ions are automatically in there. All right. So when you use word like dilute, just tell yourself, say dilute or aqueous, you know, words like that tells you that this is in it. Any questions so far?
No, sir.
All right. So we're using words dilute, aqueous. All right. Then that's in it. So, of course, that means water is in there. These are the ions present. No. All right. So now let's look at and see now what's happening to this dilute sulfuric acid. She's gonna pass current through this, and I'm just thinking that Remy is a girl. Could be a boy. I don't know that name. So, but anyway, let's say he or she is doing this experiment in the lab. Would know this. We have sulfuric acid, which has hydrogen, and water, which also has hydrogen ions. So guess what? That solution has a whole heap of hydrogen ions now. Both substances that are mixed together, because dilute sulfuric acid means say you have this and you have this. You have both of them. So you have whole heap of hydrogen ions because you get the hydrogen from the water, you're getting it from the sulfuric acid. All right. And then now in terms of the anions, now you have the hydroxide and you have the sulfate. Right. So we have two different anions there, which there are some rules for electrolysis now that, well, if we have to get into it, we get into it. But there are some rules that tell you if there are two ions present during electrolysis, two different ions present. So in this case, the two anions are different. What's going to happen is that some ions are preferred over the other. In other words, some ions require less electricity to separate. All right. Hope you're getting that. Some ions require more or less electricity to separate. So for example, when the current is passing through now with the hydroxide and the sulfate ion there, the one that requires the least current to separate, that's the one you're going to see come out in the solution during electrolysis. What happens here, as a rule, the hydroxide ion, if it's there, it's always going to get first preference. It's always going to be separated. So one of the things with electrolysis is that they wanted to predict what will be formed. All right. I remember last class, I told you that with electrolysis, no. Let's go back to this question. Told you with electrolysis that you need current, but what type of current we need? All right. We use a special type of current. Remember, I was showing you the diagram with the red wire and the black one.
Yes,
All right.
sir.
Yeah. You need a special type of current. So now I should point out to you there that electrolysis, uses DC current. We call it DC current. So this DC doesn't mean the cartridge college, but it means direct current. All right. So uses direct current. And what direct current means, it's basically plus and minus, a current that flows from positive to negative. And also I told you that there are some names that we give to the positive part of the current, the positive terminal, right? So
Like electrode and anode, sir.
well, the correct word there is the anode. It's actually the anode is the word I'm looking for. But let's get a zoom on it so I can write the name so you can see it. Electrolysis uses DC current. That is positive to negative. That's what DC is. The positive part is called the anode, and the negative part is called the cathode. All right. So bear that in mind. Remember, we're breaking down the question. We don't even start answer anything yet. We're just trying to organize what knowledge, the information, right? Because it's a lot is being said in these questions.
Sir,
Yes, go
if you
ahead.
notice, then these change those, sir. Like everything about anode, sir, that thing's negative, sir. If you understand.
Oh well, yeah.
Indeed strange, sir.
Well, all right. Look at it this way then. Uh, no, I it shouldn't be strange. You know why? Because why is the anode positive? Right? Anode means what is going there. Right? What goes to the anode?
Positive
Positive electrode.
electrons.
No. I'm saying that is what it is. But I say what goes there in electrolysis? What happens? What moves towards the anode during
Positive ions, sir.
positive can move to positive.
Oh, negative, sir. Negative.
Yeah. So therefore the anode is positively charged because the anions are going there. Okay. So
Sir, because opposite attract and CM repel, sir.
exactly. Opposite attracts. So the anode attracts anions. Everybody get that?
Yes, sir.
All right. Anode attracts anions. Cathode attracts cations. Just remember that. All right. Anode attracts anions. Cathode attracts cations. Almost sound like a tongue twister, but it is what it is. Any questions here, guys?
No, sir.
All right. We're not ready for that knowledge yet, We just want to set it and left, All right. Let's pause for a minute, digest that information, and all right, trying to there's a little this thing is freezing, man. All right, let me have too much program open. I'll close some of them. One sec. That's the close. This can close too. All right. And they'll drop off remake one. All right. I'll close this one too. All right. There you go. So just confirm that the yeah, something look like it start. All right, there you go. So yeah, so we're gonna go into the first part of the question. Define the term anion.
When an atom gain electron and it form, and you have a negative charge there.
All
The
right.
question.
All right. So for 1 mark, you should be able to get that. It's the HNL, which is good. You could have many answers here. This question has so many answers that you could even say it's a VA question. But all right. So you'd say the HNL, it's an ion that
Negatively charged ions.
you could say that, yes, or you say it's an atom that has what last or gain.
Yes.
What's the right word? Last or gain?
Gain.
Gain. Okay. Gain. Atom that has gain electron. All right. So go write down that then. Atom gaining electrons.
Sir, but you'd say it is a negative ion.
But I'm just giving you the possible answers. That they will accept. So atom gaining electrons and negative, you could say it's a negatively charged ion. Yeah. Any one of them. Yeah, those answers would be acceptable. All right. There's a negative atom gaining electron or electrons. It could be singular or plural, whichever way it will be negative. All right. No, here so. Nice something. I'll close up some of them. That's another machine. Yeah.
Sir, Google Chrome use a lot of RAM, sir, so maybe that's
Yeah, Chrome. I have some more part about them too. I close them, but let me see what I'm going for this. Let us say 81% of memory I use. Zoom I use the most.
I look on Chrome, sir, 4,000 or 4.8 gigabyte.
Oh Lord, yeah. See, Chrome I go on bad man. I have to go close up some tabs still. Alright, lock off them, some of them. I don't want them with the video look like have some yeah.
Yes, sir, like YouTube, if you open YouTube, sir, is what.
Yeah, so I have to close that. All right. Yeah, I may have some more memory for putting in this and get a chance to do it. All right. So this is for tomorrow. Physics class tomorrow. I know I'm close some of them. All right. All right. So let's go. The for the ions, so the answer here is straightforward. So I guess everybody at this stage could get the marks here. Remember now, when you see a question on a chemistry paper, it can value if it's not question 1, it values 15 marks in total. So question 1 values 25, and all the other questions up to question 6 value 15 each. All right. So this is question 4. So we know that it will actually have a maximum of 15 marks here. All right. That's if CSEC don't decide to pull a fast one on you guys. They're planning for you guys this year. They're planning for you guys this year, man. I don't know if it's in your favor or against. I believe more it's in your favor though. Because the because in the COVID and everything, I don't think, but it's still going to follow the same format though. 2 questions we're gonna mash up, 2 questions were in between. One easy question, and then the other one you probably fight your way through it. That's how they set it up. Well, 2 questions have to be in there where trouble everybody. All right. So this now in 2016, seeing this question doesn't look so bad so far. For electrolysis question, actually it's a good question so far. You get 1 mark here. All right. So the next question goes on to ask, what anions will be present in a sample of this? So we were doing this before, not true? See what anions will be present?
Yes, sir.
Yeah, so if you can remember now, tell me which anions will be present in the electrolyte. Trying to say that a while ago.
Sulfate.
Yes, very good. The sulfate, SO4.
Hydroxide.
Yeah, very good. So this, not more on this, you get your marks here. So it's the sulfate and you have the hydroxide. So you see why it's important to read the question and break it down. So you give a little, it make it work faster. You just write out them thing there. All right. So this looks good so far. 2 marks. Notice that for chemistry, you have to do more work to get the marks in chemistry. If this was a physics question, it would be 2 marks easily. But that's how chemistry is. In chemistry, you have to really work a little bit more. But all right. So no, this is it. This is where some marks coming from here. 4 marks. They wanted to draw something. No, when people say draw, the first thing people says them are not artists or them can't draw. No, this is not about being able to draw. This is about scoring 4 marks by giving them a label diagram. Notice, forget about the word draw. You're going to give them a label line diagram. Notice them say line diagram. So what? Them know on artwork. Them want lines will make sense. All right, to represent an electrolytic cell. All right. So, this is new to you. So let's show you what an electrolytic cell looks like. All right.
So we did this one at school too, sir.
Oh, I did it one. Hey, Jahar, you're there. Yeah, man, good to hear from you, man. Yeah. So, of course, you go to Chester, you will do these things. I mean, it's a great school. All right, let's go. All right. Miss Alwood teacher.
Jahari sounds like Lion King.
Oh god, yo, you see, your girl. All right, Jahari, you're impressed. The boy with your name.
No, sir, it's not the name, it's the voice.
Whoa, oh, sorry, the voice. Whoa, that's another story. No. All right. Anyway, let me show you what the cell will look like though, in a simplest way. It's a line diagram, but for electrolytic cell, this is the simplest way to draw it. As a matter of fact, maybe I should put it on a blank sheet. This thing is like freezing. All right. I'll close this one because the file they kind of big. There's no.
Sir, if you always in a water for your work.
What electrolysis?
Yes, sir.
No, it have to be
This,
liquid.
oh,
It don't
yeah.
have to be in water. Yeah, the molten or aqueous. So yeah. But if it's not in water, it have to be molten for it to work. So it's not gonna work if the compound is in solid form. But this is pretty much what they would be expecting from you guys, as this is concerned. It's you just let me say line diagram. This is even more than what them ask for, but you know you're supposed to get the gist here. Let me see now. Knock off some of them thing here. This thing has start. All right. So everybody seeing that's electrolytic cell. All right. You should be seeing it. It's on the screen there. That's what an electrolytic cell is in terms of a diagram. So in real life now, what it would be is like two batteries connected to two pieces of metal, a beaker. All right.
Two batteries, sir.
Yeah, you can use two batteries. I have to say two batteries because to get the amount of current you need for it, you need at least two batteries.
Oh, okay.
Yeah. But you can use batteries or you can use a power supply, which this will be, hopefully this might be one of the experiments that you guys do for CXC. So it's gonna be well, not sure if could be face to face. It might be face to face. So I have to go plan a day when so we do another 3 labs or more. And that's coming up soon. The one thing is this Saturday. It would most likely be probably next week Saturday. All right, so I keep you posted where that concern. But yeah, certainly there's a glitch here with the machine that are freezing taking place. So yeah, one of the disadvantage with them online thing here, you have to have memory.
I think Windows Explorer might do it to, sir, like you kind of make it run over.
Well, yeah, see, they know it run. I don't understand. I mean, let me see what happening. All right, so I look like I did graphics and so no, you know, I go smile up. Yeah, the graphics. All right, so while this is going to my school this two questions I have that's I have opened up for you guys now. All right, I'll close this one. All right, so asking for restart. So I don't know what's happening there. The restart. Hold on a sec.